Next is the capacitance, or not the capacitance, the RMS for IC. Okay, so this time we need the current through the capacitor IC. Okay, IC. Okay, so here previously we already derived the waveform for the IL, the inductor current, along with the uh, needed value such as the maximum and minimum value. Now again we are going to use the same waveform, and this time we are going to draw the waveform for the IC. Okay, so IC here. Okay. Okay, the waveform for IC will be exactly the same shape to the waveform of IL. Okay, but here the difference will be on the maximum and also the minimum value. Okay, so here we are going to use the information on the ripple value. So this is given as 8 ampere, and we knew that the average of IC will always be equivalent to 0. Okay, so same to the working of an inductor. For a capacitor, you will be first charged and then it will be discharged, so the average will be equivalent to 0. Okay, so here for this waveform, or the midpoint over here, it will be equivalent to 0. Okay, okay, so since we already know that the height is 8 ampere and the average or the midpoint over here is equivalent to 0, then from there we know that here will be 4 ampere and here it will be minus 4 ampere. Okay, and from there we can get the uh, RMS value for the RC. So I see RMS. So this time it will be IC peak, and here for a buck converter it will be over square root of 3. Okay, so for this will be 2.3 ampere. Okay, for the buck converter, the RMS value is given by this equation over here. Capacitance. Okay, we are going to use this equation. Okay, now okay, so here the equation is a little bit funny. It's stated there that the ripple output voltage is equivalent to the shaded area over the capacitance value. Okay, so this shaded area over here is this area. Okay, under this triangle over here. Okay, so now we are going to find the area of this shaded area, uh, which is a triangle over there. Okay, so we are going to need to know the height, this height, which we already got here, and then also the width of this one. Okay, so for the width of this one, we know that this is on and this is on and this is off. Okay, so that is equivalent to one cycle. So that is one cycle. So sorry, so that is equivalent to one cycle, one full cycle. So that is T. Okay, the one period. Okay, so this is 1, 2, 3, 4 parts over here. Okay, so this T1 over here, we can use the information from T over here and find T1. Okay, so T is as given from the frequency second. So T1 is 2 over 4. Okay, so 2, 1, 2, and 4 is 1, 2, 3, 4. Okay, multiply with 2, which is the time t. Okay, so this will be 10 microsecond. Okay, so we can use that to find the capacitance. Okay, so for the given buck converter with the given specification, we need to have the capacitor, the capacitance as 200 microfarad. And finally, for the last one, the last one, the maximum energy stored in the inductor. So this one will be equivalent to half L, which we already defined before, IL peak squared. Okay, so please remember this equation, and then from here this is equivalent to which is 1.92 millijoule. Okay, so now we are finished with the example 4.3.